Alright, welcome to Unit 3, Part 5, talking about how to prove lines are parallel. So we've talked about what happens if lines are parallel and how that affects angles, but there's also what's called the converse is true, and the converse just means the reverse. So we know that if two lines are parallel, then corresponding angles are congruent, but the converse is true, and that's if we know that corresponding angles are congruent, then the two lines are parallel. So that's what postulate 3.4 is saying. Postulate 3.5 talks about the parallel postulate, which says that if a given line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So for example, if I had a line here and then just a point in general, I can draw a line through point P that is parallel to this line, but only one line. Alternate interior angles, the converse, so if I know alternate interior angles are congruent, then the lines are parallel. Consecutive interior angles, remember that if they're supplementary, then the lines would be parallel. Remember, alternate interior angles are congruent, so if they are congruent, then the lines are parallel. And also, if two lines are perpendicular to the same line, then we know they are parallel. So the following notation, corresponding angles are congruent, then the lines are parallel. Alternate interior angles are congruent, the lines are parallel. Alternate exterior angles are congruent, the lines are parallel. And if corresponding or same side interior angles are supplementary, then the lines are parallel. So if you look here, if you're given angle 1 is congruent to angle 3, are any lines parallel? And the answer is, well, 1 and 3 are corresponding for A and B. So yes, it would be A is parallel to B. And the reason that justifies my answer would be if corresponding angles are congruent, then lines or parallel lines, sorry. All right, so then the next one, we'll erase that, says if angle 3 is 103 and angle 2 is 87, are any lines parallel? Well, if 3 is 103 and 2 is 87, the answer is that no, and no lines are parallel because, yes, these are supplementary, but 2 and 3 are not same side interior. They're not consecutive interior or same side interior angles. So therefore, it doesn't necessarily mean that the lines are parallel because these are supplementary. Now, if 2 and 4 were supplementary, then you could say the lines are parallel. So 27 says that angle 4 is 105 and angle 5 is 75. And it says, are any lines parallel? Well, notice 4 and 5 are now consecutive interior and they are supplementary, so therefore, yes, M is parallel to N, and the reason would be consecutive interior angles are supplementary, then you have parallel lines. Now the next one says if angle 1 is congruent to angle 5, are any lines parallel? and 1 and 5 are corresponding if you take out line M. So that means, yes, L is parallel to N. Corresponding angles are congruent. Then you have parallel lines. All right. So it says find the value of x, the measure of angle ZYN, and WXP so that PQ is parallel to MN. So if PQ is parallel to MN, that means alternate exterior angles are congruent. So that means that 11x minus 25 equals 7x plus 35. Subtract 7x, so you get 4x. Add 25, so you get 60. So that means x equals 15. And then the measure of angle WXP well, 165 minus 25 gives you 140. And then the measure of angle ZYN, 7 times 15 plus 35, that's 105 plus 35, which is also 140. So there you go. Number 30, it says find the value of x so that RS is parallel to GH. Well, notice these two angles here are alternate interiors. That means they're congruent. So 9x minus 21 would have to equal 7x minus 3. So you have 2x, you add 21, so equals 18, and then divide by 2. So x is equal to 9. So that's what x would have to be for the lines to be parallel. All right, so then looking at this next picture, it says state the segments that are parallel and write the reason that justifies if angle 9 is congruent to 13. We'll notice 9 and 13 are corresponding. So FG would be parallel to HI, and that is corresponding angles are congruent, and then the lines are parallel. If 2 is congruent to 6, those are corresponding. So that means AB, segment AB, is parallel to segment CD for the same reason. Corresponding angles are congruent, then parallel lines. Number 33, if the measure of angle 2 plus the measure of angle 4, so right here, these two, equals 180, then AB is parallel to CD. Why is that true? Well, 2 and 4 are consecutive interior, so it would be if consecutive or same side interior angles are supplementary, then you have parallel lines. If 5 is congruent to 14, then CD is congruent to HI. So here's 5, and here's 14. We'll notice CD, HI, notice they're alternate interior angles. So if alternate interior angles are congruent, that implies parallel lines. And then last but not least, it says find x so that AB is parallel to HI. If the measure of angle 1 is 4x plus 6, and 14 is 7x minus 27. So those are alternate interior, so you can set them equal to each other. So you get 3x and then plus 27. So 6 plus 27 is 33 divided by 3. So x is equal to 11. All right, so that concludes our video on proving lines parallel. Hope you have a good evening.